Hi everyone, welcome to my talk on advanced parametric modeling. My name's Brodie Fairhall. I work mostly as an automation engineer and systems integrator, but I also do product design and prototyping for various different companies. And for the last 5 years, I've been doing all of that work with open source tools, mostly freecad and KiCad. So we do a little bit of work helping educate people and companies on how to use freecad. Today we'll be discussing advanced parametric modeling. I'll be discussing tools, workflows, techniques to enable creation of really robust and highly customizable designs. In a less fluffy language, that means I'm talking about making designs that you could give to someone who's never used freecad before, some screenshots, a few instructions on how to modify a spreadsheet, and they can make massive changes to a design or an assembly and have nothing break at all. That's important because I might be giving this to customers who've never used freecad before. They might have never used any kind of CAD suite before, but enabling them to have a look at what things would look like if they make some changes without having to call me every single time something messes up, that's great for me. There are compromises. This takes a little bit more time to do. Things are a little bit more tedious, but for some certain projects, it saves a lot more time putting that extra work in at the beginning than having to constantly rebuild and fix things all the time. Some examples of things that I've actually made with this that I can show you. I've got a little customizable electronics enclosure that I use all the time. It's probably the most commonly used thing that I have built. Using these same techniques, I've made it was a demo for a customizable orthotic for a podiatrist. That eventually evolved into a full-blown workbench, but this enabled them initially to test out the theory and then to print orthotics. Also do some work for a startup called Modos who makes e-ink devices. So designing an e-ink monitor and laptop in freecad and using this parametric design methodology, they're able to make mods as well without me being the only person who can do it. And this is a really fun one, being very painful as well. It's a differentially driven camera slider. And of course, I was doing house renovation, so I used the architecture workbench and did my entire house up, and I could change some numbers and see what different walls would look like. So for everything I'm doing today, I'm using the latest development build of .21. All of this should work all the way back to .19 and will work in Real Thunder's link stage builds as well. So I've got a couple of rules or guidelines that I use to make this all work for me. And the first one is get to know your tools. I think the best way and the way that I've learned how to do all of this stuff in freecad is just to do it and to go forth and break things. So I'm going to show you how to break some sketches now. I have a spreadsheet here, got some parameters in it. I've already added aliases. If you don't know what an alias is, it's basically I can give a name to a cell rather than having to refer to like cell B3 here. Outside the scope of this video, there's a lot of good videos and resources on how to create these. So yeah, go look it up if you're not sure. It's a really cool tool. Anyway, let's make a sketch. We will draw a circle on the center X line. We'll give it a diameter from the spreadsheet. And we'll offset it from the origin point, again with a parameter from the spreadsheet. And we'll throw in one more circle attached to the same center X line, and we'll also attach it to the outside of the larger circle. Give it a diameter from the spreadsheet as well. If I can type today. Okay, we've got a fully constrained sketch here. I can't drag anything around. FreeCAD's happy with it. Everything's fully defined. So let's change some parameters and see what happens. bring up the spreadsheet, I'll put them side by side so we can see both. So if I change this offset parameter from 25 to 75, that's not the same order that I drew everything in. So let's have a look at that sketch and see what's going on. So everything's correct. This must just be one of those freecad things. It's still fully constrained. Why does freecad do stuff like this to me? Well, it's done everything that I said to. So it's still attached to that center X line. It's still attached to the outside of that circle. The issue is the order that the sketch solver will solve things and the order that I put constraints in and so on. So it's best to just follow my rule, which is use absolute references wherever possible. So I'm going to get rid of these two constraints here, and I'll detach that circle, the small circle from the large circle. I'll reattach it to that center X line. And then instead of attaching it to the circle again, I'll set a distance from the main origin point. So just a little bit of maths. I will use the same vertical offset parameter and then the radius of the larger circle. And if I can type today. So there we go. It's in the same position. It's not physically attached to that larger circle, but it's given an absolute reference for its position. So if we now go and change that 25mm offset back to 75, that smaller circle stays on top, no matter what values I enter into this spreadsheet. So for a more practical version of Sketches Gone Wild, we'll look at an older version of my parametric electronics enclosure. We'll just add some new values in for width and length, and it's doing everything that you would expect it to do. The box is changing sizes. There we go. That's what we want. So every now and then, when you change sizes in a certain direction, we'll get this. So I'll just undo this and undo it and undo it and recompute, and it's still broken. This is now permanently broken. How? Why? So I know almost every single main sketch in this is actually broken. But we'll just go have a look at the first one where I pocket into the main body. I don't know if you know what it's supposed to look like, but this corner over on the left is supposed to look like all the ones on the right. Because certain things are referenced relatively from others, we just managed to get into a combination of parameters and changing directions that cause this side to invert. So you might come across this a little bit when you have auto remove, redundant constraints, and so on turned on. You might set a constraint and it might disappear. So you can tell I put a lot of effort into this spreadsheet and released this box when it was broken. But that brings me to rule number 3, test as you go. Every time you make a sketch, change the parameters and make sure that the sketch doesn't explode on you. Every time you make major changes to the sketch, do the same thing. So if we go back to the second rule, which is use absolute references wherever possible, this basically means that we can't use any of the dress-up features. So thickness, draft, chamfer, fillet. And I know there's a model right here on the screen that has chamfers and fillets all over it, but it is fully parametric. And it's because I don't use these tools. I'm actually manually creating some of these. But yeah, the easy one is anything that you pad or pocket, you can put your fillets in your sketch. You can put your chamfers in your sketch. This also alleviates a lot of FreeCAD's problems with fillets and sketches, because you can do anything that you can draw in the sketch, you can pad or pocket. That doesn't solve the how do I put a chamfer on the top and bottom here? I can't put that in the sketch. Well, I model them manually. I use the additive and subtractive pipe tools to do so. So we'll look at a simpler example for this. I've got a basic block that I've padded here from a rounded rectangle, and I've created a little triangular profile. And you would use parameters to set the distance to make sure it all lines up. And then if I select that and the sketch that I used to create that pad, and then I use a subtractive pipe, we cut a chamfer around the outside edge. So yes, there's a lot more work than just selecting an edge and clicking chamfer, but this is topologically safe, as long as you use the sketch to do it, not the geometry. I'll do a fillet this time. I've got a lovely little fillet profile there, using the same sketch that I cut out with, and there we go, we've got our fillet. So this technique does still suffer from some of the same problems that freecad's or the Open Cascade kernel does when it comes to fillets and chamfers. So I've got a little 4mm radius in this corner of our sketch. And if I go and change my fillet profile to something that is larger than that value, so 4mm corner, so we'll make this 6mm. And yeah, now we have broken geometry, so we can't move forward with this model in this state. So this isn't just for internal geometry, this happens exactly the same for external geometry. So I'll show another little example of that. So do a chamfer on the outside. This time it's a 5mm chamfer, 3mm corners. And we've got a very similar thing happen, or exactly the same thing happen. And when I complete this, we end up with a completely broken geometry. So I do have a workaround. You're not going to want to use it all the time. It is not pretty. It's rather tedious. So I've got another little box here that I have cut out. You'll see the base is actually rather thick, but we'll see that later. I've got an internal 4mm radius, and I want to put a 10mm fillet on this bottom edge. I've done this using 3 sketches, a subtractive loft. So the bottom one is the endpoint for the fillet, and the middle one is a guide. The top one is just exactly the same geometry as the base. So if I select all of these, and then I do a subtractive loft, we now have a 10mm fillet on an object with 3mm corner, 4mm corners. If you want to do a chamfer, you just take the middle sketch out. And there we go. As I said, it's annoying, it's a bit tedious, but there might just be those times that you want to have a really large fillet or chamfer in a spot that's not possible. So that's great for single bodies, but what about assemblies? I've got a very, very rudimentary planetary gear set here, created using the assembly 4 workbench. And when I say rudimentary, what I actually mean is I am not a mechanical engineer. It's riddled with problems, so please be gentle. But what it lacks in actual mechanical design, it's a very good demonstration model for some concepts. So the first concept being making your assembly topologically safe. It's actually a really simple one. So go back to that second rule again, use absolute references wherever possible. We'll have a look at the sun gear. It's got an LCS, or a local coordinate system. That's our attachment point. That's how we attach this gear to the rest of the assembly. Typically, you would attach it to, say, this bottom circle on the geometry, this edge, but we've actually attached it to this circle in the sketch that was used to create that. Now, as long as your sketch is topologically safe, as long as it's attached to a solid reference like the XY plane in this case, that topologically safe sketch will then transfer on to making your assembly topologically safe. And it's as simple as that. That's it. That's my answer for making topologically safe assemblies. Use sketches on absolute references. So as you might assume from the video title, this is a parametric gear set. It's got user-definable parameters, and a big part of making these designs robust is thinking about who the end user might be, and then just actually forgetting about that, pretending they're a toddler who doesn't know anything and wants to destroy everything. So let's destroy everything. I'll get this all sorted out so we can look at both of them. Right, so let's pick some values that will not make any sense at all. We'll have, let's go with a negative number of teeth on the sun gear. Let's put a non-integer value in for the planets. 6,000 degrees angle and 200 planets. So we'll recompute this gear, or the gear set. And it's not good, but it didn't break freecad. It still animates. Everything seems to be in, at least in the assembly sake, working order. So how did I do that? Very simple thing. Just validating the user inputs. I run a sanity check on every single parameter that a user might input. So I have a second spreadsheet here in my parameters file called calc. Other than the ominous orange color and all of the warnings, it looks pretty much the same as the user spreadsheet. But if we look at some of these values, we'll look at the sun teeth, you can see that I'm actually running some kind of conditional expression on there. First, I'm making sure that the entry is positive by finding the absolute value. I'm making sure that it is a whole number by rounding it. And then I'm making sure that they've got at least 10 teeth. If there's not 10 teeth, it will put 10 teeth in there. So every single user parameter has some form of sanity check performed on it. And then all of the values that go out to the model and the assembly are taken from this spreadsheet, not the user parameters. So you might have also noticed that there are a lot more parameters in this spreadsheet than the user one, and the name might have given it away. This is where I do my calculations. So anything that I have to do more than once, if there's a formula that I need to enter more than one time, it gets done here. And then that means that if I need to change something formula-wise, I don't need to go digging through sketches and constraints and things like that to fix up everything. So that's enough of all the boring spreadsheet stuff. Let's do something a little bit more interesting. Let's go and change up the number of gears in this assembly, and you'll notice that there's now 20 gears. And anyone who's used assembly 4 before will know that you can't, assembly 4 doesn't create and destroy objects for your parts for you when you want to have more or less. So it's a rather interesting way that I've done this. Let's pick just one of these 20 gears and have a look. So like most freecad objects, all of they all have parameters and properties. all the fun ones are hidden. So if we right click and go show all, now if we scroll all the way to the bottom, there is a visibility field. Still doesn't have a nice little formula icon next to it, just a little drop down with true and false. If we right click on it though and select expression, you'll be able to see that I have got a little conditional expression in here that will check to see whether the number of gears is more than the value of this or the index of this gear. So, and if it's not, it'll be hidden. And so I've got 20 gears added to this, and they get hidden or shown depending on how many gears need to be in the assembly. It's not really that important, but visually it can help a lot when showing things to customers and so on, or letting them play with the assemblies themselves. Something more practical is a big bugbear of people who like to make big parametric designs is tools like the hole tool. So drag this over, and you can see that we can pick our thread sizes from a list. There's no formula icon. If you hit equals, nothing happens. But if we go and look at the properties of our hole tool, if we go and look at our thread size, we can add an expression. If I put 4 in here, and then we wait for this to recompute, you'll see that we now have a 1.6 millimeter thread, not 4. And that's because that drop-down list is an enumerated list. Number 4, the 4th item in that list is M1.6 size. So if I put in an expression here, I can now check when someone enters 1, it will return M1 as a string. When someone enters 2, it'll return M2. I've done M1, 2, 3, 4, 5, 6, and 8. I did not keep going because I didn't want to be writing this expression out for half an hour. And then if it doesn't find any of those values, it'll just return M4. So if we apply that and we go and check out our spreadsheet, with 1 parameter, and we change that here, that expression will check that parameter and turn 4 into M4, and we get M4 threaded holes. Change it to 8, we get M8. And because of the way the expression's written, if I enter something crazy like 55, then we get M4, because that was the default that I entered in that expression. So for the last example that I have for you today, something I'm actually pretty excited about, we've just got a simple 2020 V-slot extrusion. But what if we wanted it to be a 2040? Or what if we wanted it to be a aluminium box section? Or something even crazier and more different, we can make it some C-beam. So I know a lot of you have immediately thought, oh, config tables. But this is something pretty different. I'm excited about the prospects. You can see how quickly that updated every time I changed it too. So all we really have here is a shape binder and a pad. Not the pad. If we look at the shape binder, we've got an expression, a nice long conditional expression like before. But I'm actually taking the support shape from a whole bunch of different shape binders. So every time you pick something different from that list, it's actually going into this little group here where there's a pile of sketches and a pile of shape binders. I haven't been able to work out how to make it directly pull sketches, but we've just got a pile of sketches here, and every sketch has a shape binder. And then every time I pick something in that drop-down box, that shape binder will pull the shape binder support, which is the sketch, from a certain shape binder. So this is something I've never seen anyone else do before. Whether or not it's a good idea is yet to be determined, but it's going to allow for the creation of some very, very wild changes in geometry with some very, very simple implementations. Anyway, that's all I have for you today. All the examples I've used in the presentation can be found on my GitLab, which I've got linked. If you want to see what else I'm up to, you can find me on YouTube, on Mastodon, Twitter. Thanks for watching, and thank you to the organisers and sponsors for making this event even possible. And I'm looking forward to chatting to you all after the presentation.